So the second part, in this part, we'll discuss the structure questions from the test paper. Figure 1.1 shows a distance time graph for a cyclist traveling between point P and V on a straight road. Remember, whenever you have a distance time graph, the slope of distance time graph represents the speed. So you have to identify just the trend in the slope, and using that you can work out the speed. So from Q to R. So Q to R, it appeared to be a straight line. So it means the slope is constant. So when slope is constant, it means the speed will be constant.
Mister, is it not acceleration, constant acceleration?
No, it is zero acceleration. Because when it's a speed, it's a distance time graph. If it was a speed time graph, then we'll say it's a constant acceleration. But because it is a distance time graph, the slope represents the speed. So speed is not changing, the speed is constant. Acceleration is zero. From R to S, what happened? As you can see from R to S, it appeared that the slope is decreasing. So if a slope is decreasing, what does it mean? It means the speed is decreasing. And from S to T, it is a horizontal line. Whenever there is a horizontal line, it means the slope is zero. It means the speed is zero. Speed zero means the object is stationary or object is at rest. So if it is a straight line, it means constant slope. If it is a horizontal line, means slope is zero. Or slope can increase in this manner, or slope can decrease. So these are the four possibilities, the shape of the graph. From R to S, because the speed is decreasing, when decrease in speed is also called deceleration. So that is also acceptable. That is also correct. If you write deceleration, that is also correct. Why deceleration is correct? Because speed is decreasing, and decrease in speed is called deceleration. So it is not wrong. It is also correct. So either you can say speed decrease or you can say decelerating. Here you can say speed is constant, or you can mention zero acceleration. Then calculate the speed between U and V. So we want to calculate the speed between U and V. So we have to calculate how much distance is covered between U and V. Or we can, it's a straight line, so we can find the gradient.
Yes, Mister, it's 160 over 100.
Yeah, so the numbers, because see, each box is representing 20. There are 10 boxes from 0 to 200. So each box is representing 20. So this is 440. So 440 to 600. So it means that is 160. And from 300 to 400, that is 100. So that is equals to 1.6 meter per second. Then after point B, the straight road continued down a steep hill. The cyclist traveled down steep hill. He does not apply the brake, and all resistive force can be ignored. Look, when you're coming down the hill, naturally what happened? Your speed start to increase. So when something is rolling down, so what happened? The speed will increase. So we have to sketch a graph for an increase in speed. So how we can represent the speed is increasing? So the slope should increase. After V, we should, if you draw a straight line, it means the speed is constant, but that is wrong here. Or if you draw a horizontal line, it means speed is zero. If you draw a curve down, it means speed is decreasing. If you draw like this, it means speed decreases. But because as it is coming down, speed is increasing, so the slope should also increase. As a distance time graph, the slope represents the speed of an object. Figure 2.1 is a top view of a small ship which is having a mass of 1.2 into 10 to the power 6 kilogram. The ship is moving slowly sideways with a speed of 0.04 as it comes into a dock. Like a dock means where the ship stop, or you can say hangar. The ship hits the wooden pillar which moves towards the dock wall. Calculate the kinetic energy. The formula for kinetic energy is half mv square. So you just have to use the formula for kinetic energy, which is 1 by 2 mv square. So it is half mv square, so 1 by 2 m, which is 1.2 into 10 to the power 6, 0.04, and then square will be there. So this will be give a very large value in exponent.
Mister, I made it half by 12 with 1, 2, 3, 4, 5, 5 zeros, multiply 0.0016.
Why 0.0? Okay, 0. You squared it before. Yeah, that's right. That is also
Yes,
correct.
yes, okay.
So
it gives me 960 kilojoule.
Yeah, 960 kilojoule or 960 joules.
No,
No, Mister.
960 joule.
960 joules should be there. When you solve, it will give 960, 960. Because the SI unit, kilojoule means if it was like 960 and then 3 zeros are there in joule, so then I will say it is 960 kilojoule. But it is directly 960, so the final answer will be 960 only.
Yes, okay, Mister.
The unit SI unit of energy is joule. It can be kilojoule depending on the value. If the value is too big, then you will write in kilojoule. Then a ship is in contact with a pillar for 0.3 seconds. As it comes to rest, we have to calculate an average force. Look, there are two ways to do this question. One is, as the ship is moving, the ship is having a kinetic energy. So to stop the ship by the dock, there will be a work done. And work done is equals to force into distance. So we can use this method, or we can use the formula. We have to get the resultant force, the formula F is equals to ma. So we already have the mass of the ship is already given. To get the acceleration is the change in the velocity divided by time interval. So how to work out the change in velocity? The initial velocity was, as the ship was initially entered the dock, it was having a speed of 0.04. And they mentioned the ship completely stops, comes to rest. So the final speed will be 0. So acceleration is 0.04 minus 0, because final minus initial, or it will be 0 minus, because it is final is 0 and initial is 0.04 divided by time interval, which is 0.3 seconds. So this will give us the acceleration of the ship, and after calculating its acceleration, and I will get a negative answer. Why I'm getting a negative answer here? Because this negative answer only shows that the object is decelerating. Whenever you get a negative acceleration, it means the object is slowing down or it is decelerating. But for calculation point of view, we just need the magnitude here. We just need the number. So we'll use the formula F is equals to ma. The mass is 1.2 into 10 to the power 6 and acceleration is 0.13. So when we multiply them, we'll get how much force this ship will experience when it is stopped. So it's a large number, which is 1.6 exponent 5.
It was Mr. 160,000.
Yeah, the exact answer, basically in the marking scheme, the answers are rounded off. But this is the correct answer, 156,000 Newton. Or you can, when the number is too large or big, you can convert into exponent. So I can also write 1.56 into 10 to the power 1, 2, 3, 4, 5 Newton.
Mr.
If
Frankly,
you
I
round
wrote
it
it.
off, yeah, if you round it off to 1.6 into 10 power 5 Newton, that is also correct.
But Mr. I didn't
Yes,
change like standard form. I wrote it with zeros. Is it true?
yeah, it is correct. But
Yes. Okay. Thank you.
being a science student, when the number is too big or too small, better represent your answer in scientific notation. And how to convert in scientific notation, if you find by yourself difficult, on your calculator there's a button ENG. When you get the number and press this button ENG, your calculator will convert that normal number into scientific notation. Then we have to assume that the kinetic energy which we calculated used to do a work done. So calculate the distance. So work done is equals to force into distance. The work done is the kinetic energy, which was 960. The force which we calculated 1.56 into 10 to the power 5. And the distance we don't know. So this is multiplied, other side it will be divided. So 960 divided by this value, 1.56 exponent 5. So we will get, I think, 0.1, 0.5 some 0.0061. Okay. Yeah, that's right. 0.0061 meter. Then dock walls sometimes have a pillar replaced with a rubber car tires. Explain how this reduces the possibility of a damage when a boat docks. So basically what happened, rubber, they can elastically deform, so it can absorb greater amount of energy as compared to wood. Wood is a rigid material, it cannot deform when object collide, but rubber is a plastic material, elastic material, it can deform. So if the object take longer time to stop, it means it will experience a small force. Like if you're running towards the wall and suddenly you hit the wall, it will have a greater impact on you. But if you have a foam in between the wall and you hit, that time you will take a relatively longer time, like that moment you will take a longer time, so which reduce the force on you. So the effect of the rubber, what is the effect of the rubber? The rubber is a elastic material. It's of only 1 mark. I am just explaining the whole answer, but you can write in short that it increases the time for the collision, like time for the boat to stop, so which reduce the force. So rubber is an elastic material which increase the time for the ship to stop, reduce the acceleration or the and the resultant force.
Mr.
Yes.
Mr. I wrote it. It's reducing friction and contact. Reduces contact. Is it true?
Reduces friction. Yeah, it is acceptable.
Okay.
But better way, try to write in terms of momentum, like relating a time, acceleration, and a force, because you are calculating a force. That's why your answer should include the force as well.
Okay, Miss.
In question 15, the structure question, as you can see, there is a submarine which is in a seawater at a depth of 3 exponent 5. The density of a seawater is 1030. Calculate the pressure due to seawater on the top. So the pressure exerted by the liquid depends on the density, gravity, and depth. So pressure is equal to density, gravity, and depth. Density is 1030, gravity is 10, and the depth, that is 3 into 10 to the power 3 meter. So when we multiply these factors, we'll get 30.9 exponent. Yeah, that's right. 30.9 exponent 7. So this will be 30.9 into 10 to the power 7, and the unit SI unit is Pascal. Look, some question, this density is given in gram per centimeter cube. So you have to convert the gram per centimeter cube into kilogram per meter cube. And remember, gram per centimeter cube to kilogram per meter cube, we multiply by 1000. Even though it appeared that kilogram per meter cube is a large unit, but remember, whenever we are converting gram per centimeter cube to kilogram per meter cube, we multiply by 1000. Here we don't have to convert as the unit is already in kilogram per meter cube. Then a submarine emits a pulse of a sound to detect the other object in the sea. The speed of a sound in a seawater is 1500 meter per second, and echo is received with a delay of 0.5. Calculate the distance between the submarine and the other object. So, for example, if this is a submarine, it sends the sound and it bounced back from the object. So, whenever there is a reflection, the formula speed is 2d divided by t. The speed of ultrasound, that is, or sound 1500 to distance we don't know, and the time is 0.5. So it will be 1500 multiplied by 0.5, which is 750, and 750 divided by 2. So this will give a 375. So 375 meters will be there, the distance between the object and the submarine.
Mr. Why it's divided to?
Because in the question, when the submarine emit the sound hit the object and then bounce back. So the distance covered by the sound going distance d and returning back d. So the total distance is 2d. So when we calculate the distance, that distance is twice. So whenever there's a reflection, the formula is speed is equals to 2d divided by t. So you need distance, so it will be speed multiplied by time divided by 2. This is always the case of an echo or a reflection. Another pulse of a sound is emitted through air. Remember, speed of a sound in air, when we compare the speed of a sound in solid, liquid, and gas, the sound travels fastest in solid, followed by liquid, and the slowest in the gas. 5000 in solid, 1500 in liquid, and only 330 or 300 in gases. So another pulse of a sound emitted through the air when the submarine is on the surface. So submarine is on the surface and it is emitting a sound. An echo is received from a second object that is in the air, and it is after same time interval, 0.5 seconds. So after the pulse is emitted, compare the distance of the second object from the submarine with the distance of object which we calculated. Look, because this object at the speed of the sound is only 330 meter per second in air, and in water it is 1500 meter per second, the speed of a sound. So there is an object in the water and there is an object in air. So when the submarine sent the signal and it bounced back in 0.5 seconds, and here also submarine sent the signal and it bounced back in the same time interval of 0.5 seconds. So when we want to compare the objects, whether the object which is in air is closer as compared to object in water, or it is the same distance or larger. So the correct answer, the distance of object which is in air will be smaller, because the speed of the sound is slow. So sound will take relatively like travel slower speed And that's why even you can use this formula. You have the formula, speed is this 2d over t. Why 2d over t? Because there's a reflection. So the distance will be speed multiplied by time divided by 2. So speed in air, it is 330 multiplied by time is 0.5 and divided by 2. So 330 multiplied by 0.5, which is 165, and 165 divided by 2, that is 82.5. So this object which is in the air is 82.5 meter away from the submarine as compared to the object which is underwater, which was 375 meters. So reason that speed of a sound travel or speed of a sound is slower in air. So this was the alternative to practical. A student investigate the work done required to pull a box containing some masses up a slope. This we already did, so I'm not discussing the planning experiment. We already discussed the alternative to practical, and this is the same question we just discussed in the last session.